All right, this is Mixed Angles Day 4. We're going to start with the warm-up. It wants to know if AB is tangent to circle O at K, find the measure of angle BKO. Well, AB, they just reminded you, is a tangent, and we know OK is a radius. And we have a rule that if a radius meets a tangent, it forms right angles. So angle BKO would equal 90 degrees. All right, number 1. Again, we have two tangents drawn to a circle from an external point. We've got a couple radii in the picture, and angle C is 40 degrees. They want the measure of angle DAB. I'm going to put an X right there. So that rule is actually happening again here, where a tangent is meeting a radius. So we have a right angle there and there. Now, this is a little challenging because we don't have a shape like a triangle that we're used to. We actually have, I'm going to call it a quadrilateral because it is 4 sides. And if you remember, like an angle adds up to 180, a quadrilateral adds up to 360. Well, we already know one of the angles is 90, another one is 90, and the last one is 40. So if we add all of those up, we get 220. So 360 minus 220 leaves us 140 to go right there. So that would be our answer. All right, number 2. In our diagram, we have chords AC and WF. We have a diameter. AC and WF are parallel, so I'm going to put our little arrows there. And angle AFW is 60 degrees. They want us to find the measure of arc AC, so I'm going to put an X right there. Well, let's talk about what type of angles we have. This angle right here is called an inscribed angle. And you might notice a Z happening right here. So we can actually take that 60 and put it right there. An inscribed angle has the rule where the mouth opens up and goes all the way across and does what? It doubles. So this would be 120, and the same thing is happening right here. Now, we have our diameter right here, and that is actually cutting our circle in half. So halfway around would be 180. So 180 minus 120 would leave us with 60 right there. So arc AC would equal 60. All right, moving on to number 3. In the diagram, we have two chords intersecting. This should look pretty familiar, and they've labeled the arc 70 and 90. We want angle BEA, which is right here. This is what type of angle? Central? No, because it's not at the center. Inscribed? No, because it doesn't touch the circle. It is called an interior angle. And it goes with this arc and this arc. So our formula is interior angle equals arc plus arc over 2. Our angle is missing x, and our arc is 70 plus 90 over 2. So we end up with 160 over 2, which gives us 80 degrees. All right, number 4. We have a point P in the exterior of a circle, where two secants are drawn. All right, so I'm going to use my space here to draw a circle. Now remember, secants touch twice. So I'm going to draw one crossing twice, and I'm going to come back and touch twice again. Now notice how they both have the common letter P, and it says point P's in the exterior. So this must be P. Now in order for his name to be P-A-B, I have to go backwards. P-A-B, and this one's P-C-D. Angle P is 42 degrees, so let me sneak that right there. And arc AC is 20. They want us to find arc BD, so I'm going to label that X. What type of angle is this? It is an exterior angle, and we will be using these arcs right here. So exterior angle equals arc minus arc over 2. We know the angle this time. It's 42 equals, our big arc is X minus our small arc is 20 over 2. I'm going to put this over 1 so I can cross multiply. When I cross this way, I get 84. When I cross this way, I get X minus 20. Plus 20 plus 20, and I get X equals 104. All right, on to the back. We have a hexagon inscribed in a circle. That means all 6 corners are touching. And they want us to find angle ABD. Well, ABD is right here, and that's this angle. This is a central angle? No, because it's not at the center. It is not interior because it's not crossing inside. It is not exterior. It is called an inscribed angle. And if you look at this like a mouth, it is actually eating all of this arc. But wait a minute, there's no numbers on the picture. But if you actually look, the circle's being broken up into 6 equal pieces. So if I take 360 and divide by 6, I will get 60. That means each of these are 60. Well, our angle is eating this much, which is how much total? 180. But when we go back to here, remember it shrinks in half, and all of this would be 90. So angle ABD is 90 degrees. All right, big question for number 6. We have a circle with some chords, a diameter, a secant, AE and FD are parallel, and then we have some ratios, which means AE is 5x, ED is 3x, and DG is 1x. We have a few things over here they want us to find, but I've got to start with what I got. We have 5x, 3x, 1x. How much of the circle is this making? Half of it. So that means 5x plus 3x plus 1x equals 180. 9x equals 180. Divide by 9, x equals 20. So this must be 5 times 20, 100. 3 times 20, 60. And I'm going to erase so I can fit this. Oops, looks like I'm not able to erase here. Well, I'm going to put a little 20 over the picture there. All right, so they want to know how much angle D or arc DG is, and ended up being 20. Next up, angle AEF. AEF is right here. It is an inscribed angle. So I look at its mouth and it goes way over here. Uh-oh, we don't have anything here. But there is a Z. So this is the same as this. Do we know anything about this angle? Yes, its mouth is going over here. So if 60 is over here, this would be 30, which means this would also be 30. So it is 30 because we took 60 and cut it in half. Next up, angle DBG. DBG is right here. What type of angle is it? That's the question you should ask every time. Central? No. Inscribed? No. Interior? Yes. So we're going to do interior equals arc plus arc over 2. Now, which arcs are we going to use? We're going to use this one and this one. Uh-oh, we don't have this one, but there's a clue. This 30 right here makes this 60. So the arcs we want for DBG are 20 and 60. So we do 20 plus 60 divided by 2, which is 80 divided by 2, and that gives us 40. And I'm going to put it in there nice and tiny. DCA is right here. What kind of angle is that? Central? No. Inscribed? No. Interior? No. Exterior? Yes. So we're going to do exterior equals arc minus arc over 2. So the big arc is way over here, 100. The little arc is right here, 20. So I do 100 minus 20 over 2. 80 over 2, 40. So I'm going to sneak a tiny little 40 right there. And the last question is angle CDF, which is right here. Now, it's not central, it's not inscribed, it's not interior, it's not exterior. It's nothing. But you want to know what it is? It's in a triangle right here. And I see an angle 40, 40, and a missing angle. So all we have to do is 180 minus 40 minus 40, and we get 100 for the top of that triangle. Those are tricky because there is so much going on in that picture. Real quick, the last one. EF is parallel to AB. There are several ways to do this question, but I'm going to do it the quick way. If these are parallel, this 60 can slide over here, corresponding like a puzzle piece. This 60 is a central angle, 60 same. And now this X is opening up and eating this 60 right here, so I can come back and cut it in half, 30. All right, that is it.